Okay, in this video we are going to be discussing integration. Now integration is the opposite of differentiation. So let's just recap what differentiation actually means. So let's do the derivative here. You'll remember you take the 5 and you put it down in front. So what that will give us here is 5 multiplied by 2/5 x to the, and then we reduce the power by 1, x to the power of 4. Derivative of 7 is just 0, so we have this guy right here. That's it. Now we can simplify him a little bit. This 5 and this 5 will cancel each other out, leaving us with a derivative of 2x to the 4th. Derivative of all this blue stuff is 2x to the 4th. Integration is doing the exact opposite of that. So notice here we have what's going to be called the integral. That's what this symbol means. This dx just says we're looking at the x variable. It says with respect to x. So we are doing the integral of 2x to the 4th. So we do the opposite. We take x to the 4th and we make it x to the 5th. Instead of putting the 5 in front to multiply, we divide by 5. And then the 2 that we have in front just comes along. Now, because of this 7, I'll talk about that in a minute, we have to put a plus c here at the end. So then what we end up with is 2x to the 5th over 5 plus c. That is the answer to this problem of integration. So what's this plus c doing here at the end? Well, notice up here, the derivative of this was 2x to the 4th. But notice that if that was a 71, it would still be 2x to the 4th. And if it was 710, it would still be 2x to the 4th. So this value here at the end, that's a constant, could be any number and still produce the same derivative. Therefore, when we do the integral, we don't know what this number is going to be. It's not determined. Now, we will be determining it later on, where we'll be doing something called definite integration. But for now, it's indefinite integration, and we just leave it as plus c. So let's look at 2 more examples here. So in this one, we have 3 terms. We just integrate each term individually. So it will be helpful for us to recognize that this 12 is really 12x to the 0. So x to the 1st divided by 1, we don't have to write that, and the 12 just sits in front. Minus 3, this is x to the 1st, so it's going to be x to the 2nd over 2, and then the 3 just comes down in front. Plus, here we have x to the 2nd, so it will be x to the 3rd over 3, and there's a 1 right there, so we'll put a 1. And then we can put, we need to put plus c. If we want to rearrange things and make it look a little nicer, we can do it like this. 1 over 3, x to the 3rd. I'm writing the biggest term first. You don't have to do this, but you can. 3 over 2, x to the 2nd. That's this one with the minus that came along with it. Then plus 12x. I'm not going to write the first. It's there, but I don't have to write it. And then plus our constant, plus c. So if you wanted to check to see if you got it right, just take the derivative of this and it will produce this guy. In a little bit different order, but it'll still produce him. Okay, let's try this one over here. Now, sometimes we can get a little tricky with 2 pi. 2 pi, you might think that this is a variable and treat it like a variable, but it's not a variable, it's a number. So these are just 2 guys that come along for the ride. In here we have x to the 0. So what we're really going to end up with is x to the 1st. With a 2 pi in front. Now a common mistake is just to write your answer like this. Now let's change colors. Common mistake is to say that the answer to this problem is 2 pi x. However, we forgot our plus c. Put the plus c and you have arrived at the final answer. Okay, these are examples of basic indefinite integration. It's called indefinite because we don't know what the c is. However, we're still doing indefinite integration, but here are 2 examples that require a little bit of work before we can even integrate. You remember if you wanted to if you want to differentiate this guy, you have to rewrite him first. Well, similarly, before we can integrate him, we need to rewrite him. So this becomes x to the 5 over 3 dx. So now we're going to integrate him. We raise 5 over 3 by 1, and it becomes 8 over 3. You can do that on your calculator, 5 over 3 plus 1. I'll just show you. This is really plus 1 here, but I'm going to write it as 3 over 3. And now you can see where the 8 over 3 came from. We must not forget our plus c. So then from here, this is not looking very nice at all. So let's flip the bottom guy and multiply. So we'll get 3 over 8, x to the 8 over, that wasn't a very nice 8, x to the 8 over 3 plus c. Now, up here, we have something similar. Again, we just need to do the rewrite before we begin. So, negative 5, x to the, we can move this up there, and he becomes a minus 4 dx. So now we're ready to integrate. We take our minus 4, and we increase that by 1. So minus 4 increased by 1 is minus 3 over minus 3, and the negative 5 just stays in front. Cleaning this up just a little bit, we'll make it 5 over 3 x to the negative 3 plus c. That's one way we could write this. Or, if we wanted, we could also move that negative 3 down into the denominator, and it would be 3x to the third plus c. Either of these would be okay answers. All right, I have one more I'd like to do in this video, and that is an example of when we have something like this. We'll have the integral of, say, x squared minus 25 over something like x minus 5. So what are we going to do in this situation? Well, we don't know how to integrate something like that when we have fractions with variables in the denominator, so we need to somehow simplify this. And what we can do here, we'll change colors again. What we can do on this one is we can factorize the top. It becomes x plus 5, x minus 5. The bottom is x minus 5. So then if we do a little canceling, we have an x minus 5 here and an x minus 5 here. That means we will have the integral of x plus 5 dx. So let's come up here and actually do our integration, which will mean we take our x to the first and we'll make it x squared over 2. We will take our 5, which is really x to the 0, and we will make it x to the first over 1. I don't have to write that. And the 5 comes along for the ride, plus c. Now, again, as always, you can check your work. I'm not checking it, I'm just rewriting it here, but if you want, you check your work by doing the derivative. Do the derivative of this guy, and you will see that you get this. And simply because we just simplified that, this is our answer.